Ions conduct electricity.
An ionic compound in a solid state will not conduct electricity.
But an ionic compound in a molten state or in solution does conduct electricity, such as standard salt in solution.
The test. To prove that our statement is true, that ionic compounds in solution will conduct electricity, we attempt a simple test.
By creating an electrical circuit which involves the current going through sodium chloride aqueous, we can see if the ionic compound in solution really can conduct electricity. In our circuit we have a power supply, a light bulb, the ammeter, and carbon electrodes, and sodium chloride in solution. Now just check that the electrodes are working. So the circuit does work. Right. When we put the electrodes in normal water, the light bulb does not turn on. As the water does not conduct electricity and the circuit is not complete. When salt is added to the water, and the electrodes are put in, the light bulb does turn on as the salt solution does conduct electricity. But why? The polar nature of water breaks up the electromagnetic charges that hold sodium chloride together. Water pulls the cations and anions apart.
When the ions are pulled apart, they are free to move and carry the electrical charge with them from the cathode, positive electrode, to the anode, which is your negative electrode.
Because NaCl conducts water when in solution, it is known as an electrolyte.
So, as you can see, all the chlorine ions are going to the cathode, and all the sodium ions are going to the anode. And also the hydrogen in water is also becoming an ion as well. And the electrons pass from the positive electrode to the negative.
As a result of electricity passing through NaCl aqueous, the chlorine in NaCl is released as chlorine gas.
Chlorine gas can be seen to be bubbling at the anode.
Using litmus paper, we can prove there is chlorine gas present. Where is?
Put the electrodes back in. Damp blue litmus paper turns red to show chlorine is present. The reason the litmus paper turns red before white, being bleached, is because the chlorine reacts with the water soaked in the damp litmus paper, forming hydrochloric acid, which is acidic. The chlorine then kicks in and bleaches the litmus paper.
The colours started to fade, as you can see. And soon it'll turn like red and bleach.